All right, so in our first part of our example, we went through and found the convolution of t and e to the 3t, and we found out that it was equal to negative t over 3 minus 1/9 plus 1/9 e to the 3t. The next thing we're going to do is go in and now take the convolution of both sides to verify that this, in fact, does hold up. And doesn't verify or prove the theorem, but it's a good demonstration of the theorem. So we're going to take the Laplace transform of the left side, which is t convolution e 3t, and that is equal to the convolution of the right-hand side, negative t over 3 minus 1/9 plus 1/9 e to the 3t. And once again, we're going to use linearity on the Laplace transform. So we're going to have a negative 1/3 Laplace transform of t, which is 1 over s squared, minus 1/9 Laplace transform of 1, which is just 1 over s, plus 1/9 Laplace transform of e to the 3t, which is 1 over s minus 3. Now we're going to go in and get common denominators for this large fraction, and that common denominator is a 9, an s squared, and an s minus 3. So for the first term, it's missing a 3 to build the 9, and it's also missing the s minus 3. For the next term, it's missing one of the s's, and it's missing the s minus 3. And then for the last term, it is missing the s squared. So when we go through and add these up and get common denominators now, we're going to have one common denominator of 9 s squared s minus 3. Upstairs, when we distribute, we're going to have a negative 3 times s, and then we're going to have a plus, let's see here, and then it's like plus 9, and then we're going to have a minus s squared, and then my plus a 3s, and then for the last term, we're going to have a plus s squared. And now if we combine like terms in our numerator, we will notice that the 3s's will cancel out, the s squareds will cancel out, and we're left with the fraction 9 over top of 9 s squared s minus 3. And these 9's cancel out as well. So our final answer is 1 over s squared times s minus 3. And if you look at this, this is the product of the Laplace transform of t, which is 1 over s squared multiplied with the Laplace transform of e to the 3t, which is 1 over s minus 3. So you will notice here that we have now demonstrated, and again, this is not a proof by any means, but this is a demonstration of the convolution theorem, which once again states that the Laplace transform of the convolution of two functions, t and e and negative 3t, is just the product of the two Laplace transforms.